Algebra 1, this video lesson goes with the review packet I've given you for Chapter 7. And as the review packet indicates, you really are only responsible for 3 sections of Chapter 7, all of them talking about systems of equations. Now, the review packet is a Xerox copy from the test I gave you back, must have been maybe even a couple of months ago now, but at that point I was saying you had to use at least one of the 3 methods at least once. Those methods being graphing, substitution, and linear combination. Well, forget about the must. Forget about the at least once. All I want to make sure is that you understand, all I want to make sure out of this video lesson is that you understand these 3 methods. They are all there to help you, and there are going to be some situations where one is going to be easier for you than another. So this video lesson should cover each of those methods so you at least know them. Here's the first problem. Remember, a system of equations is just 2 equations. Could be more, but all we've talked about were 2. 2 equations representing 2 lines, and you're trying to figure out where those lines cross. When they cross, you found something that works for both of them. So in this case, these look pretty straightforwardly easy to graph. We know how to graph when we've got a slope and we've got a y-intercept, and we have that for both of these things. So there are those graphs of those 2 lines. The one with the intercept of 3 is this equation, and it has a positive slope of 1/2. That's this line. This one here has an intercept of -4. It belongs to this line here. But the place that they cross, that's what we're interested in. That place where they cross is -4, 1. Some equations, though, like this one, aren't as easy to graph. That's all right, because there's actually a method that most of us, back when we were studying this, considered an easier method for solving systems of equations anyway. And that's where you try to find either x's or y's that can easily be canceled. And notice in this case how the 4y and the -4y are set up just waiting to be canceled. If you cross those out, you're left with putting together -4 or combining. Remember, it's called linear combination. Combining the -4x with the -3x gives you -7x. And combining these gives you 7. Well, if -7x equals 7, then x equals -1. And you're already halfway to your goal of figuring out the point where the 2 lines cross. You know x is -1. Plug that back in to either equation. I chose to plug it back into the top equation. -1 times -4 is +4. And you keep the rest of the equation. Plus 4y equals 12. And then you solve for y. You move the 4 over. You divide by 4. You're going to find that y equals 2. And there you have the complete solution to your equation, to your question, to your system. That's the point where these 2 lines cross. A slightly more complicated situation comes up with question 11. There's not any case, you can't cancel the x's, you can't cancel the y's right now. But remember, we learned to look for ways to make it not too hard for us to cancel. If I doubled everything in the top row, actually if I multiplied everything in the top row by -2, look what would happen. I'd have 3x times -2, or in other words, -6x. But more importantly, -2 times this would make +12y. And now these guys are ready to cancel. Don't forget, though, I still have to multiply this times -2, and it becomes +12. So now when those guys cancel, I'm going to be left combining -6 and 4, which gives me -2x. Combining 12 and -24, which gives me -12. Solve for x. You're going to find that x is 6, and once again you're halfway to your answer. Put 6 back into any of these equations. When I say any, if you've crossed these out so much and scribbled them so much that you can't read them anymore, you could put 6 back into one of these equations. I chose to put it into the bottom one here. 4 times 6 is 24. I keep the rest of this equation, as I've written down here, and now I'm going to solve for y. I move the 24 over, and I get -12y equals -48. I divide by -12. I find that y is 4, and there's my answer. Even more challenging is question 12. I don't know how to graph this, but it's really not going to be easy for me to make these cancel just by multiplying one of the rows. Well, I can multiply both the rows. And if you run into this situation, notice what happens if you multiply the two by their inverses. So where I have 5 here, I multiply it by 7. Where I have negative 7 here, I multiply it by 5. Multiplying through the top row, 5 times negative 7 is negative 35x. Going all the way across here, 5 times 10 is 50. But make sure you multiplied everything by that 5. On the bottom row, 7 times 5 is 35, and now these guys are going to cancel. I've got a negative 35x and a positive 35x. Multiplying all the way across, everything times 7, I end up on the right side with negative 5 times 7 is negative 35. Okay, now combine these. Negative 35 and 35 cancel out. Negative 20 and 35 combine to make 15y, and these guys combine to make 15. Solve for y by dividing by 15. Y turns out to be 1. Once again, I'm halfway to my answer. This time I've got the y, and I have to find the x. I plug this back into, well, once again, any of these equations. This time I chose to put 1 in here, into this one. 5 times 1, I'm sorry, into here, into this y. 5 times 1 is 5. Got myself confused there for a second. So it's 5x plus, well, that made 5, equals negative 5. Move the 5 over. I'm going to have 5x equals negative 10. Divide by 5. I'm going to have x equals negative 2. Plug that in, and I'm done. The only question left to show you, oh, I'm sorry, there are 2 more. But one of the 2 questions that's left to show you is a word problem. The hardest part about this, and you might want to hit the pause button and read this to yourself if you haven't read it in a while, but the hardest thing is to figure out what the system of equations is. So go ahead, pause, read, and when you come back, I'm going to show you that system of equations. Okay, I'm going to assume that you've done that. I came up with this. $5 times the adult tickets plus $4 times the student tickets made $90. Again, remember from an earlier video lesson, standard form works well when you have 2 pieces that add to make a total budget, and this total was $90. Well, here's the second equation, the $39 day. Well, I can't cancel these right now, but it's not hard. If I multiply the bottom, if I multiply the bottom row by negative 4, then now these will cancel. So 4 times negative 4 is negative 16a. 4 times 39, I had to pull out my calculator, but negative 4 times 39 is negative 156. These cancel. Combine these, you're going to get 11a, or I'm sorry, negative 11a. Combine these, and you're going to get negative 66. Divide both sides by negative 11, and you'll find a is 6. And once again, you're halfway to your answer. The adult price tickets are $6. Plug a back into any of these equations. I chose to plug it into the top one here. 5 times 6 plus 4 times the student price equals 90. And solve for s. 5 times 6 is 30. I move that over. So I've got 4s equals 60. Divide both sides by 4. I'm going to find that s equals 15. Done. That's my answer. The adult tickets cost $6. The student tickets cost $15. Now, I did say there was one more problem. Sometimes it's just not convenient at all to cancel, and graphing is a pain. I could graph the top one, but the bottom one you might not like to graph. There is a third method called substitution, and every once in a while it is the best method available. It's not my favorite, and many students didn't like it, but some do. Some swear by it. If I know that y is the same thing as 2x minus 7, I can substitute 2x minus 7 any place where I see y. So I'm going to substitute it into this bottom row. Instead of negative x plus 3 times y, I'm going to have negative x plus 3 times this stuff, 2x minus 7. And it's still going to be equal to negative 6 just like it was before. Distribute that 3, and I'm going to have negative x plus 6x minus 21. Put these x's together, I'm going to have 5x. I also have to move the 21 over. So 5x equals 15. Divide by 5, I'm going to have x equals 3. And once again, I'm halfway done with my problem. I'm not going to show you again because I've shown you so many times how to plug the one answer in to get the other answer. You should know now how to plug 3 into these equations, or you could have plugged it into this equation if you wanted to. I'm sorry, no you won't, because there's no y there. You have to plug it into one that has y in it, don't you? So that is worth reminding you. Plug this 3 into either of these equations, and you should be able to figure out that y is -1. That's where those two lines cross. That's the end of this video lesson.